Hello eye tracking community, my name is Michael and this is video number 100 on our YouTube channel. Before we go into the video, I would like to say thank you. Thank you to all of you all around the world for being interested in learning something new about eye tracking analysis, and how to use Blickshift Analytics, the gold standard for eye tracking analysis, to bring your eye tracking data analysis on a next level. So thank you so much. In this video, I will give you a quick overview about the main features of our software. We will discuss 4 main application fields. The first one will be how we can analyze a dynamic eye tracking experiment. The second one is a classical desktop eye tracking experiment. And the third example, I will show you some data from an automotive eye tracking experiment. And finally, in the fourth example, we will have a look into how you can analyze eye tracking data from virtual reality with Blickshift Analytics. In the description, you will find all the time markers. So if you're interested in one specific topic, you can directly jump to this topic, of course. Also, please have a look at the other tutorials on this channel. As I said, this is the 100th video on this channel. So there are many more videos available. Most of them are about how to use Blickshift Analytics. So there you can get a very detailed overview about all the features of our software. But we also provide more general eye tracking how-to videos, like for example, how to design an eye tracking experiment, how to conduct it, and also videos about the basics of eye tracking. So it's really worth to browse around and to learn something new. So let's start now with the video today. First use case, dynamic eye tracking experiment. On the screen, we can see a dynamic eye tracking experiment where the participants had to walk around in an office space and had to get some information from visualizations that were located in the office. Just to show you quickly how you can use Blickshift in such a setup. On the right side, you can see the video as it comes from the eye tracking exporter. So you can see the head-mounted perspective, the ego perspective of the participant, and this yellow circle here indicates the fixation. In this case, it's a pupil lapse eye tracker, and the green circle indicates the gaze point. Here on the left side, you can see a bit more information. Here you can see the fixations, but not only the current one, you can also see fixations going to the past. So in this example, 3 fixations into the past. I can quickly change this parameter here and say, perhaps I'm interested in 30 fixations going into the past, and then you get a better overview of the situation in general. Some eye trackers have the possibility to define areas of interest beforehand, like in this example here with markers. We can have a look at the data as it comes from the eye tracker. So I scroll here to the parallel scan path visualization. And if you have AOI data available, you can quickly visualize that either with a parallel scan path visualization, which you can see here, or with a bar graph visualization, as you can see here on the right side. So there are different ways how you can visualize AOI information from the experiment. Sometimes markers are not a good technology for defining areas of interest. Sometimes you cannot use them because of difficult light conditions. If you cannot use markers in your experiment, you might have a look at our dynamic AOI editor powered by artificial intelligence. The important thing is that all the calculations, so the detection of the areas of interest, are computed locally on your PC. So there's no connection to the internet, all runs on your local PC. Here we can see how it works. As I said, we've used markers in this experiment, but there are also situations in the experiment, like for example, when the participants have written their answers on a sheet of paper where we could not define areas of interest by using markers. If this is the case, we can define areas of interest here with our dynamic AOI editor, and this dynamic AOI editor automatically tracks the areas of interest for us. If we want to combine the areas of interest as they come from the pre-processing step together with the areas of interest from the dynamic AOI editor in Blickshift Analytics, we can use the column computation node, as we can see here with a small script, and the result is shown here. So in this parallel scan path visualization, we can both now see the areas of interest as they come from the pre-processing step together with the area of interest as it has been detected by the dynamic AOI editor. And now we can compute case statistics. So we can go to the case statistics node, and here we can see the classical case statistics for all the areas of interest. So the preprocessed ones, but also the ones which has been defined in our software. We provide up to 20 different eye tracking metrics with this component, and the only thing which you have then to do for your later analysis is just to make a right click, say output, export to files, then the software creates CSV files for you, and then you can use these CSV files for your statistical analysis. Sometimes we want to combine eye tracking data with other biometrical data. This is very easy in Blickshift Analytics. We just import the other biometric data here with the data source biosensor. We merge this data with the eye tracking data with the merge and resample node, and then we visualize the data in Blickshift Analytics. So on the left side, you can see the transitions over the areas of interest, and on the right side, you can see the corresponding galvanic skin response value as it comes from the biometric sensor. So this was a very quick run through some of the features of our software which we provide for dynamic eye tracking experiments. If you want to learn more about how to analyze dynamic eye tracking experiment data, please have a look into the playlists or browse through our YouTube channel. There you will find a lot of different examples how you can analyze this kind of data very, very efficiently with Blickshift Analytics. In the next example, I want to show you how you can analyze eye tracking data from a desktop eye tracker. On the screen, we can see a classical desktop eye tracking experiment with a static stimulus. Participants had to get some information here from a bar graph. Here you can see 9 scan paths. You can also visualize the data with heat maps, also of all the participants, if you like. And then you can compare both of them, for example. You can also define areas of interest for the different areas on the stimulus. And like in the example before, you can quickly let Blickshift compute the standard eye tracking metrics for these different areas of interest. A great component in Blickshift Analytics is the diagram component. You can directly visualize the results of the case statistics node, either for one participant or of some of them in one diagram. So you don't have to leave the software and go to another visualization software. You can do that all in Blickshift Analytics. Perhaps you have recognized this little yellow selection in the previous example. This is the result of a sequence search. So where I search for a specific eye movement pattern. If we look at the scan path visualization, we could imagine that there are different eye movement patterns which are typical for this visual task. And one, for example, could be that the eyes are alternating between the peak of the bar here and the y-axis. If I want to test this hypothesis, I go to the sequence search. I search for a sequence which is here defined as bar peak to y-axis. And then I go into the visualization. And here, the yellow sections highlight this eye movement sequence for me. So whenever we can see here in the visualizations, this yellow section, this pattern has been found. And this is a very powerful tool to quickly check some hypotheses which you might have in your eye tracking experiment. Also, what you could do with Blickshift is to let the software search for typical eye movement patterns. This is the sequence analysis. So let's have a look at the result. These green sections now are eye movement patterns which occur in all the participants. So all of these patterns here occur at least for one time in a data set of a participant. This component makes it very simple to compare different eye movement patterns of different groups of participants if you, for example, correlate the participant identifier with demographic data, which is also very simple in Blickshift Analytics. This is Blickshift Analytics for an automotive use case. We've imported some data from a car drive, and I will show you in real time how you can visualize now this data set. So I go to the data source, I visualize the velocity of the car. I add the real situation, which has been recorded from a camera here from the backside. I add the situation. So there's some context information available. Here I change the color. And then finally, I add a visualization for the areas of interest which have been focused during the experiment. On the screen, we can see now more than 6 minutes of data recording. As you have seen, it took me roughly 1 minute to set up this visualization dashboard here. And from here, you can go now into the eye tracking analysis. Like I've shown in the other examples, you can define areas of interest. You can correlate your eye movements with the car information. If you have biometric data, you could also bring that into your analysis, and you can search for patterns or let Blickshift Analytics search for patterns for you. Finally, the last example for today. On the screen, we can see eye tracking data from a virtual reality eye tracking experiment. Along with our software, we provide scripts that bring the eye tracking data from your VR framework into Blickshift Analytics, and the result could look like this. So in the center on the screen, you can see the real situation as it has been seen by the participant. Here on the right side, you can see the areas of interest which have been hit by the gaze vector. And on the left side, you can see the projection of the gaze vector on the visualization. So here in the center, you can see now this bar graph with these purple bars. And on the left side, you can see how this blue fixation is wandering around as the participant gets some information from this virtual visualization here in this virtual reality. And on the right side, you can see again the classical parallel scan path visualization to visualize the transitions over the areas of interest. We can also now remove the whole dynamic scene and focus only on the different visualizations as they have been presented to the participant. Here we can see now one specific visualization. So we collected all the fixations on this one specific area of interest and visualize this area of interest here for the 3 participants. And we can do that also for the other visualizations. If you have watched the other parts of this tutorial also, you have now an idea what you can do next. You can do quickly a gaze statistics. You can let Blickshift search for the typical eye movement patterns. You can search for a specific eye movement pattern to prove a hypothesis. You can label the data. You can correlate the data with biometric sensor information or with the position of the user or with some click information from the controllers. The possibilities are endless here. In this video, I wanted to give you a quick overview about some of the possibilities of our software. There are many more possibilities and features which this software provides. You can find a lot of examples on our website. You can find the tutorials and the how-tos on our YouTube channel. And if you have questions, please contact us, ask us. We are happy to help you with your eye tracking analysis. Thank you very much for watching this tutorial. If you like this tutorial, please push the like button, subscribe to our channel, and activate the bell so that you'll never miss a new video on this channel. And I'm looking forward to seeing you in the next tutorial.